Welcome to AD Academy. The main motto of this channel is AI for Aam Janta. My name is Dr. Ayan Devnath. I am an IIT Delhi alumni and Fulbright research scholar at Harvard University. I have total 9+ years of experience in the field of artificial intelligence, deep learning, machine learning, NLP, generative AI. Let's watch this video. Welcome to my metaverse. Now we will discuss about the transformer architecture first in a very overview manner, and then we will deep dive into the architecture. Attention is all you need is a paper which has been published by some researchers from Google Brain and University of Toronto, which is a game changer in the NLP, since transformer has drastically changed and dramatically improved the performance of the models in large language model or in NLP. Here we are seeing the paper, attention is all you need. The interesting thing you should note is that the first author of this paper, Ashish Vaswani, is also an Indian. Thus, Indian brain is highly recognized all over the world. This is the transformer model architecture. Now let's check the simplified version of the architecture. Here we are saying that it is an actually extension of the sequence to sequence model which I have explained earlier in my previous video. In sequence to sequence, it has two parts. One part is the encoder and the another part is the decoder. Thus we are giving input to the encoder, and within the encoder it has some architecture consists of an RNN or maybe of LSTM, and then it gives out context vector to the decoder, where decoder is also having similar architecture as that of encoder, and then it throws output. This concept of sequence to sequence has been expanded and transformer architecture has been made. Thus transformer has two parts. One is encoder part, another is decoder part. Let's take an application where we are doing language translation. We are giving English sentence as an input and we want to convert it to French sentence, which will come as an output of this transformer. I don't know French, so just I am putting dash dash, but it has some words in it which is actually in French. Now note that while we are giving English sentence to the computer, it will be not able to understand anything because computer understand only numbers, and thus we are converting each and every English words to a certain number. Here I am giving an example of an English input sequence as I am a boy. So each of the words I am a boy are getting converted to a number. And how this number is formed? So in English dictionary we have all possible words, and all possible words are numbered in certain way, and this number has been used here as a token IDs. There are different ways of doing tokenization. This process is called tokenization. So after we are converting it into a tokenizer, this tokenizer is actually fed to the encoder using embedding layers. So what is embedding layers? These token IDs are actually a certain number, but this number will not give you the importance of the other words in the sentence, and as a result this number has been expanded into a vector space, into a vector. So here each words, say I am a boy, first converted to numbers 12, 53, 90, 125, or some numbers will be there, and then these numbers are converted into a vector space x1, x2, x3, x4 respectively. This process is called embeddings. Thus the numbers are getting converted into a higher dimensional vector space where it can capture many more meaning and context and weightage of a word with respect to other neighboring words or with respect to all of the words in the sentences. Please subscribe to this channel, like and comment, and share this video with all of your data science enthusiast friends.